In this lesson, Factoring Review, we are going to figure out which method of factoring we should use. We have covered a lot of methods of factoring. Each method can only be used in certain circumstances. Knowing which method of factoring to use is incredibly important. So step one is you always try to find a greatest common factor, or sometimes we call that a GCF. And you always try this method first. If you can factor out a GCF, you probably have to do more steps in trying to factor it, but it's going to make your problem much more simple and much more factorable. After you've taken out the greatest common factor, then we're going to ask ourselves the next question, which is how many terms do I have in order to decide which method I'm going to use. So if I have two terms, which is a binomial, then we will use some sort of formula. Okay, there are three formulas that we know in order to factor: a squared minus b squared, which is called a difference of squares. Difference of squares factors into a plus b and a minus b. Then we have a difference of cubes and a sum of cubes. Now we learned the sum of cubes and difference of cubes together because they were very, very similar. That one was a minus b and a squared plus ab plus b squared. And for the sum we have a plus b, a squared minus ab plus b squared. As a reminder, those two are going to use the SOAP, same, opposite, always positive on your signs. Okay, that's same for the difference of cubes, same, opposite, always positive. Okay, so if you have a binomial, after you factor the GCF, then you have to use one of those three formulas. If you can't use one of those three formulas, then you can't go any further, and we call that prime. The next option would be three terms. If you have three terms, we call that a trinomial. And the trinomials, we break them up into two groups. If a is 1, then we have an easy set of trinomials. That would be like x squared plus bx plus c, where this leading coefficient out in front is 1. In that case, all you're doing is you're going to put an x in the front, and you're looking for two numbers that add to the b but multiply to the c. But if a is not equal to 1, where we have ax squared plus bx plus c, where this a out in front is not 1, because if a is 1, then that's an easy thing to do. But if a is not 1, then we have a little bit of a harder trinomial. Sometimes we call this the easy trinomial, and this one the harder trinomial. Okay? So if we have the harder trinomial, then you have a choice. You can either guess and check, or you can use the AC method. This is like one of the only times in factoring where you get to choose your method. Most of the time, the problem dictates whether it's a difference of squares or an easy trinomial or a hard trinomial. In this case, if it's a hard trinomial, then you get to pick which method that you like better. So if it's 4 terms, that one doesn't have a nice, cute little name like binomial or trinomial. That's just a 4-term polynomial. If it's a 4-term polynomial, you must use grouping. Now, after you've decided what method you're going to use, if it's a binomial or a trinomial or 4-term polynomial, the last step, step 3, says, is the polynomial completely factored? Because even if you've done the factoring that you think that you're supposed to do, there might actually be more to factor. Okay, so step 3 is to always check to see if there is anything else that can factor some more. Note, if nothing factors, not even a GCF, nothing factors from the original problem, then you can say that the polynomial is prime. But if one thing factors, like if you can factor a GCF out, then don't write prime. Prime would only be if nothing factors at all. So for the following exercises, we're just going to determine which method of factoring to be used, and then we're going to factor. So on the first one, step 1, is there a GCF? Well, amongst all 4 terms, there isn't anything that's common. See, A is in the first 2, but it's not in the last 2. B, nope. C, no. There's nothing in every single term, not a number, not a variable, that can factor out of every single term. So then we go to the next step. The next step says ask how many terms. How many terms do I have here? Well, I got 1, 2, 3, 4. So because I have 4 terms, I know I'm going to use grouping. So when I'm grouping, I'm going to take the first 2 and put them in a group, and then I'm going to put the last 2 in another group. I'm going to use 2 different colors. In the blue group in the front, I'm going to factor out a GCF. So if you want to take your fingers and cover up the red group entirely and just try to focus on the blue group, then you're going to factor out anything that you can. In this case, the only thing you can factor out is an A. So I'm left with 3C plus D. Alright, now cover up the blue group and just look at the red group. Now the red group starts with a negative, and the general rule of thumb here is if the first term of your group that you're factoring has a negative in it, you're going to factor out a negative. So I'm definitely going to factor out a negative, and I can also see a B common. Negative 3BC divided by negative B is positive 3C. Negative BD divided by negative B is positive D. Looking at these 2 terms now, I have one long term here and one long term here. Between those 2 terms, what do you see common? Well, I see this parentheses, 3C plus D, is common in both. If I factor out 3C plus D, then I'm left with A from the first term and minus B from the second. So I've now completed step 2. I factored. It was a 4 term, so I grouped. And then I have to do step 3. Is there anything else that can factor here? No. Is there anything else that can factor here? No. So now I know I am completely factored, and this is my answer. On the next problem, step 1 says, is there a GCF? Well, between 5r cubed and 5, it looks like there's a GCF of 5. So step 1 is done. I have factored out a GCF. Step 2, looking at whatever's left inside the parentheses, how many terms do I have? Well, I have 2 terms. R cubed is a term and 1 is a term. So because I have 2 terms, I have to look at my list of formulas. Which formula does r cubed plus 1 qualify for? Well, it looks like a sum of cubes. So in my answer, I know I'm going to have a 5 because that's the GCF. I'm going to have a 2 polynomial and a 3 polynomial. As I'm prepping here, I want to make sure that I'm thinking about what is being cubed. On the first term, r is being cubed. On the second term, 1 is being cubed because 1 times 1 times 1 truly is 1. So therefore, I'm going to use my formula. The r goes in the front and the 1 goes in the back of the binomial. On the trinomial, remember we take the first one times itself for the first term, the last one times itself for the last term, and then the one in the middle is just like a little compromise, one of each. So r times r gets me r squared. R times 1 is r. 1 times 1 is 1. Then I'm going to come back and use my SOAP. Same. My original problem had a plus here, so I'm going to have a same plus there. O stands for opposite, so I'm going to have a minus, and then AP is always positive. And that's my answer. On our next problem, x squared plus 3x minus 11, step 1 says to use a GCF. Is there a GCF between x squared, 3x, and 11? I don't think so. Step 2, how many terms do we have? 1, 2, 3. 3 terms. So because it's a trinomial, I have to ask myself, is a equal to 1? Well, yeah, a is equal to 1. Yay! That means it's an easier trinomial. I can put my x and my x here in the front. Then I'm going to be looking for 2 numbers that multiply to negative 11, yet at the same time add to 3. So let's list our factors of 11. Now because it's negative, that means I'm going to have a positive times a negative. So I can have 1 times 11 to, you know what, 1 times 11 is the only factors of 11. So can I use 1 and 11 to add to 3? No. There's no way that I'm going to multiply any two numbers that multiply to 11 yet add to 3. So because there is no such numbers that do that, I'm going to cross off this method. There was no GCF. I couldn't factor using my methods for an easy trinomial. So therefore, I know that this problem is prime. I have done everything I could do, and nothing that I could do factors.